Good morning, everyone. Good afternoon, good evening, depending on where you are around the world. My name is Nathan Heston, and I'm an energy solutions trainer here at Briggs & Stratton. I'm joined by my colleague, senior trainer, Daniel Moyer. Good
Hey
morning, Daniel.
Nathan. Hi.
Welcome, everyone. So today's training is being recorded, and you will receive a copy of this recording. We'll email that to you tomorrow. It is also NABCEP certified. So if you're here looking for those continuing education credits, please stay through the end. Send us an email with your name as it should appear in your NABCEP certificate, and we'll get those sent over to you. You will receive a copy of this slide deck as well, so no need to ask that. We're going to run through the training deck here together. And as we get started, I want to encourage you to make use of the Q&A feature. So Daniel will be monitoring Q&A. We will be pausing to answer questions as needed. So welcome, everyone. Let's go ahead and jump into the material for today. So just want to note as we get going that Daniel and I hit the road and are out there running trainings together with some of our colleagues from Briggs & Stratton. The next places that we will be are listed up here. So we are going to Oregon Solar Storage Conference, or at least I'm going to be there delivering a training, and I look forward to connecting with you if you're in the Portland area and are going to OSEA. Daniel, where are you headed to?
So I'm going to head to Hawaii, Honolulu, and we're going to be supporting the Hawaii Solar Energy Association. And I think, Nathan, this is a good opportunity to talk about how Briggs & Stratton Energy Solutions and all of you on this call should support your local state-based solar storage association. So Oregon, right? OSEA is a great one. Hawaii's got one. California Solar and Storage Association is another one. The national one, SEIA. So wherever you are in the country, consider joining one of these organizations. They're really out there lobbying and fighting for the rights of our solar and storage installers. So please join us at one of these events and consider joining your local chapter.
And one other benefit to joining is that you get access to resources. Daniel, I know when you were creating your NEM 3.0 talk, you made good use of CALSA's members only a reference area, and you were able to get resources from CALSA, which is where we live. And so some of these organizations provide you access to online resources that you wouldn't have if you didn't join.
Yeah, specific to your state.
Yep. Okay, so one other thing to point out, if you are an installer and you're on this training, we do want to make you aware that we have a bonus offer. If you have not installed the Briggs & Stratton ESS system before, we have a special $1,000 off bonus for your first purchase of an ESS through us. As well, if you do join our installer network, we have an installer network across the world. We'd love to get you on our map. Join our elite installer program. We can get you $100 off of each battery that you install. So if you install 10 batteries in a year, you get a $1,000 check from us. And that's an ongoing promotion as long as you're part of our elite installer program. If you're interested in that, there is a QR code on your screen. You could scan that, or you could scan that once we send you the slide deck tomorrow. If you're interested in getting help in designing your first ESS, you're welcome to use that phone number there on the screen. That'll connect you to sales application engineers that can answer some questions you might have. So Daniel, what are we looking at here?
So we're looking at our line of standby generators, and the definition kind of a standby generator as opposed to like a portable generator is one that's like permanently mounted at your house. So it's usually piped into either your natural gas or the propane tank that's on the property. These always use an automatic transfer switch. So we have a lineup of our starting at 10 kilowatt up to the 26 kilowatt air-cooled generators. Those are all 240 volt. And then additionally, we have our commercial size generators that can operate either on 208 or 483 phase as well. One of the unique things about our generators, the great technology, is called NG Max. So on all of these generators, if you run a generator on propane, say it's a 22K generator, you're going to get 22K of power out of it. But these generators derate when you run them on natural gas, not ours though. So we're able to now have adjusted some of the ignition timing so that we now can produce 22 kilowatts, whether you're running it on propane or natural gas. So we're really excited to offer these. These can, and we're going to talk about this here in the talk, Nathan, about how you can combine the two together as well. So take a look at our generator lineup. I will say the only one that doesn't have the automatic 2-wire signal to start is that 10K. Every one of these other ones has the ability for 2-wire signal to start. So that hybrid inverter, like a solar, can automatically start it based on the state of charge of the batteries. One of the most common whole home backup in the country really are these standby generators. Like I mentioned, they all use an automatic transfer switch. So the generator will detect when the loss of utility occurs. It will start itself up. The transfer switch, which is kind of in the center of the screen there in that diagram, will recognize the loss of grid and the presence of generator and transfer over. So there's a lot of advantages to using this kind of historic way to do it. There's always a lot of power. And usually, if you have natural gas or a 1,000-gallon propane tank, it's kind of in a lot of ways unlimited fuel. That being said, there is some options and availability now with these much more high-powered inverters, such as the Sol-Ark 15k, where now we can combine energy storage systems and generators together. You can reduce that fuel usage, reduce some of the noise associated with the generators, the fumes, and really also the maintenance that are associated with long run hours on these generators. But again, this is historically how we've seen it, and it really wasn't till the advent of lower cost, high quality, long cycle life energy storage batteries like the ones we have at Briggs & Stratton Energy Solutions, and the much more powerful hybrid inverters that are coming to the market like Sol-Ark, that now we've been able to kind of move towards a whole home backup architecture using energy storage systems, whether or not you leverage one of these generators or not.
Yeah, and Daniel, one of the things that you didn't mention here that we're showing is that this transfer switch that is on the screen has the ability to do some load shedding as well, and gives you the ability to control what loads are coming on. So you could, I think we're showing a 26K power protect there, but you could actually back up your whole home with a smaller generator if you are careful to make sure that you don't overload that generator. We can do something similar with inverters now as well. And so we'll talk a little bit about that in these slides coming up. What we're looking at now is a transition really from generators being the most common backup system for a whole home in the country to more and more customers looking at using batteries for the same application, or potentially combinations of generators and batteries to back up their whole home if they experience long duration outages. As Daniel mentioned, that Sol-Ark inverter that's out there, the larger inverter, lower cost, costs have come down on making large inverters. 200 amp pass through. We now have the ability to pass all of the current from the grid through the inverter and to the loads of the home, and have that inverter there waiting on an outage, and the transfer switch is built in, right? We have that the relays built into that inverter so that it can automatically manage power coming from the batteries or coming from the utility to power the loads to the whole house. What I like about the packages that we're about to introduce to you is that they are from two American companies, right? Game-changing companies, really. Briggs & Stratton has been making, through SimpliPHI, has been making LFP batteries since 2010. We're way out there in terms of developing IP, making progress on long cycle lives, long duration batteries with high power outputs. And we're going to talk about that a little bit today. And then Sol-Ark has really led the market in terms of whole home backup with the introduction of that 200 amp pass through when they brought the 15K out. Boy, I guess it's about 5 years ago now.
What it saves installation time, right? So you just back up, no more pull-in loads.
So let's look at whole home backup with an inverter, right? And the big difference between battery backup and generator backup has to do with transfer time, right? And ultimately duration of backup as well, right? Batteries are a more expensive way to store energy, but they also offer a lot of advantages. And we're going to talk a little bit about that. Prices, yes, are coming down. I think you'll be pleasantly surprised with the prices per kilowatt hour of our newest battery offering, that 6.6 that's shown on the screen. But let's talk about this. In the center, we have an inverter. And that inverter, and Scott, unfortunately, we don't have the ability to unmute, but if you go ahead and pop your question into the Q&A, Daniel will be able to read that off and we can answer it. So we've got an inverter here at the heart of an ESS system, and we are recommending the Sol-Ark inverters. Their software is excellent. We've got a long history with Sol-Ark, closed loop integrations, and just excellent overall performance with Sol-Ark. So we're looking at an inverter there, which is really the interface between managing different power sources. You can pull the power in from the grid through the inverter, power the home's electricity. You can monitor with an app. And you can additionally manage power flowing into and out of the batteries, either charging from the grid or alternative sources. You can easily integrate solar, DC or AC coupled solar. And you can also easily integrate a generator. So generator integration with Sol-Ark is a fairly easy thing to do, and we'll talk a little bit about the ways that you can do that today. The batteries that SimpliPHI offers, our current battery offerings are shown on the screen. The two batteries on the left side of the screen are some of the workhorses throughout the US. We've got a large number of batteries, hundreds of thousands of kilowatt hours of these 5 batteries are in the field powering backup on cabins, on homes, on commercial businesses, etc. The SimpliPHI battery is a newer version of the PHI battery that offers closed loop communications. The same battery pack, same long duration battery pack, a 15-year unlimited number of cycle warranty on that battery, with closed loop communications. And so that's a nice advantage of having that. You can use Energy Track, our remote monitoring platform, to keep track of individual batteries, their state of health, how they're performing, etc.
Nathan, we had a couple of questions come in.
Go ahead, Daniel.
So can you speak a little bit to why would we choose to be an inverter agnostic battery company and maybe not have our own inverter? And why that allows us to pair up with different inverters? What are some of the advantages of doing that?
Well, I think it allows installers the freedom to choose which inverter they're most comfortable with and continue using that one, which is either popular with their customers or popular because of some of the features that they offer. We are promoting the Sol-Ark inverter here as compared to some of the other ones, mostly because of that 200 amp pass through and because of the software. But a lot of customers, have a long history with Outback, for example, or a history with Schneider, and we want to honor that. I think that in terms of producing our own inverter to compete with these larger inverters, it is a big lift to do something like that. And our expertise has traditionally been in batteries. SimpliPHI has always been an inverter agnostic company. So I think I'll leave it at that. You said you had a couple of questions. I want to make sure we have time.
Yeah, of course. Another one, and Andy's asking about, he's got an off-grid project. In a lot of ways, when we do these whole home backup, we are taking our homes off grid. And he's got a couple specifics. So Andy, go ahead and email us. Our email is energy
storage training.
Thank you, at basco.com. We have a whole team of sales application engineers that will allow you to help design and size out that system. So I'll go ahead and put that in the chat right now. Reach out to that as well. And then Kevin's asking about what's the FLA of the inverter. So maybe that's locked rotor amps, Kevin. Anyway, we'll talk a little bit about the capabilities of starting motor loads, I think is what
I think
Kevin's
full loaded
asking.
amps, maybe. But yes, I think essentially what he's asking is for the inverter that I showed on the screen, amperage, I'd have to do a second to convert. I can tell you it's 24 kilowatts. So that should be 240. Sorry, I'm giving you amps DC. Amps AC. Daniel, I'll let you do that quick conversion for me here to get it. But I think you're looking at somewhere around 160 amps AC for the inverter when it's surging. It can surge up to 10 seconds to get those big compressors started, etc.
Yeah, and if you do have one of those big compressors, there's a lot of soft start modules out there nowadays. And I'm also really impressed by a lot of the inverter-driven compressors, those heat pumps. They don't draw as much as those big old clunky air conditioners back in the day. So, but combination of between looking at the soft start and the specs, you should be able to make it work.
Yeah, I'll give you an example. There was a recent video that Scott Hunt put out showing starting up a 135 amp 3.5 ton compressor using a Sol-Ark 15k, and it was able to do that. But to reduce that load on the inverter in case other loads in the house were running, he did put on a soft start there, and that soft start reduced that 130 amps down to something like 28 or 27. So it is worth it to look into those soft starts. They're generally, a $300 item that really reduce those, those loading amps when that compressor is getting started. So I'm going to highlight the two outdoor rated batteries that we have are both wall mountable. The one on the right, our newest battery, are the SimpliPHI 6.6, comes in a stackable format. So really increasing the ease at which you can install this battery. It's outdoor rated, floor mount or wall mount, and we'll show some examples of this in just a second.
And Nathan, Andy's asking the difference between those 4 batteries. They're all LFP, right?
They are all LFP. So they are all LFP. There are some differences between them. The same types of cells are used in the first 3 batteries that are there on the screen. We have switched the type of cell in that 6.6 to offer more power density. We're using a blade style LFP pouch cell, but it's offering excellent performance at a higher power density for us. So that's how we're able to pack more power, more duration of backup into a smaller package. And it's our most advanced battery offering to date. We've kind of continued the superior safety and longevity that we have been known for in this business. The power output of this battery is very high. In fact, a single stack of these batteries can operate at 1C continuously on the discharge side. And so we're looking at 4,500 cycles at 100% depth of discharge, 6,000 cycles at an 80% depth of discharge. And Daniel, I believe that's actually at 1C, not 0.75. So I think I have a typo here on the screen. And again, we're sticking with the LFP battery chemistry. We have enhanced the electrolyte a little bit in this newest battery, and that allows us to offer lower temperature operations. So this battery can discharge when ambient temperature is from -4 Fahrenheit all the way up to, I believe it's 135 Fahrenheit. And then it can charge from 14 Fahrenheit up to, I think it's 128. I don't know the exact transition there, but I'll show you those on the screen in a little bit. So there's a wide temperature range that we can operate in with this battery. You can stack these batteries in single stacks, double stacks, triple stacks, and you can see the overall power output there. So that 20 kilowatt hour stack is probably the most popular, but you can do combinations of stacks as well. So you can do multiple stacks, up to 6 of them, to offer you a very large system, 120 kilowatt hour backup system. And we'll show you some packages to give you an idea of how much backup time the typical home would get. But note the power output there, very high, 14 kilowatts out of a single stack. Now, the Sol-Ark 12K is a little bit limiting, or 15K is a little bit limiting there. You can only do 12 kilowatts of continuous power out of the Sol-Ark from batteries. But if you've got solar, that Sol-Ark 15K can do 15 kilowatts of power.
Nathan, please go back a slide. And
Sure.
Thank you, everyone, for putting in these great questions. So we used to do the old lead acid batteries. I would say C over 20 or C over 10, right? That means that you would discharge the battery in 10 hours or 20 hours. And 1C, right? You could discharge it 1 hour. So why do we start to use the inverse? Somebody's asking, what is 0.75C and what's 0.5C, right?
Yes.
And again, I think that typo is correct. It should be 100% depth of discharge for the 6,000 cycles. And I think what we're kind of getting at here is that we used to always think about the depth of discharge as how long is the battery going to last and how many cycles you're going to get out of it. But really what we found with some of these new chemistries, right, is that the rate at which you charge or discharge or how hard you make the battery work more affects the life. So talk a little bit about maybe why are we starting to use the inverse? And I know we've talked about this before, Nathan.
Well, let me just explain what that means for everybody that's on the call, right? So if you're not familiar with the battery lingo, a 0.5C is the ability to discharge half of the battery's capacity in an hour, right? So that C rate is your ability to discharge the energy that you have stored in that battery per hour. So 0.5 C is half of the battery. 0.75 C would be 3/4 of that battery in an hour, right? And so you can figure out how long your charge cycles would last. But let me give you an example of why this matters. Let's suppose you've got a system that's got a generator integrated, and you'd like to use that generator to charge up those batteries when they get low, and then shut that generator off so you're not using expensive fuel. Well, if you can charge and discharge your batteries quickly, if you have a high C rate, you could keep that generator on for a short amount of time, right? 2 hours to charge your batteries from 0% to 100%, and then you shut that generator off quickly. And then you have the ability to discharge your batteries from 100% again. So having that generator off. So why are we using the difference there? I think it is kind
and
of
not C over 2. Why not C over 2, but 0.5 C?
I guess it's just a little bit easier, I think, for customers to understand. So it's a variation compared to the size of your battery bank as well. So I think it was just, we were asked to use this because it's a little bit easier for everybody to understand. You're discharging half of your battery's capacity in an hour, or 75% of your battery's capacity in an hour. And the numbers don't always work out to nice fractions, right? For the 0.75 C, right, it would be 3C over 4, right? Or, having the numbers switched up a little bit for numbers that don't work out to exactly a denominator of a certain number of hours. So that's why we've switched up to that, but that's what those numbers mean there. So, the ability, like a single stack of these batteries can discharge at 1C. That means that whole battery can discharge itself in an hour. Why would you want a high C rate? Well, maybe you have some big load that's going to come on, and you want to be able to power that load. So we just used that example of somebody wanting to know what the overall maximum output of the Sol-Ark inverter was. Well, if the batteries don't have enough output power to power that inverter, right, you would need a very large battery bank to just maybe get your air conditioner running, etc. So we want to make sure that the battery stack has the power. So we're giving you these numbers here on the screen. Some of this is just so you have it for a reference, but again, a 3-stack can do up to 14 kilowatts of continuous power and has the ability to surge to 300 amps on the DC side as well. If you do need large quantities of our 3.8 batteries, or you're mounting them outdoors, those batteries are not outdoor rated, but we can make them outdoor rated with these NEMA 3R cases. And so these are, I'm showing you our Boss 6 and our Boss 12 battery cabinets. Another nice thing we can do beyond making the batteries, putting the batteries in a enclosure which offers ventilation, temperature-based ventilation, is we can put an inverter in this cabinet as well. And so traditionally, it's been quite a common product for us. This is called our access cabinet. It kind of comes with everything included, including the bus bars and the DC cabling, all included in that package. So you kind of get a plug and play option. Now you still have to connect it to the load center of the house and install your critical loads panel. But this is an option for our 8 and our 12K inverters from Sol-Ark, as well as we have a Schneider option as well for these. I want to point out the Sol-Ark's lineup just so we know what we're going to be talking about. We are focusing on that one in the center, that Sol-Ark 15K. And we are focusing on that Sol-Ark 15K mostly because of that 200 amp pass-through. It allows us to back up the entire home for most US homes. Now, I understand some homes are bigger, that some of those homes in the Hamptons have 600 amp service, I've heard, right? But for most of our homes, I have 100 amp service at my home. Daniel, I think you have 100 amp service at your home. But most customers have 200 amps or fewer. And so just a single one of those inverters allows you to back up most homes with the pass-through. Now, Sol-Ark offers 8Ks and 12Ks. They are limited in their pass-through to only 63 amps. So though you could back up a whole home, you'd be severely limited using the smaller inverters. Then the two inverters on the right side of the screen that you're showing, we do have battery offerings with those. Those are for high voltage projects. So 208 would be that 30K inverter and a 483 phase. would be the 60K inverter that's there. Those are Y configuration inverters. You can't do delta with them, but you could with a transformer. The Sol-Ark 15K, if you combine multiple inverters and you can parallel up to 12 inverters, you can also do 208 output with the Sol-Ark 15Ks too. Sol-Ark 15 and 12Ks, you can do 208 output. You can do 208 with as 3 legs of 208 with as little as 2 inverters, but if you want a balanced system, you should use 3, 6, 9, or 12 inverters for 208 applications. We're going to focus on the low voltage inverters, meaning low voltage battery input at 48 volts. And we're going to specifically focus on what's shown on the screen. That's the Sol-Ark 15K. It's an excellent choice for whole home backup. I'm showing it with our 6.6 batteries. Yes, that conduit is undersized. I think that looks like 3/4 conduit. What you really want using there is 2-inch conduit. This is a marketing photo. I wish I had the skills to update that conduit with Photoshop. But this is a nice version of kind of what this would look like if you installed the inverter and the battery outdoors, as you're welcome to. It's outdoor rated. Showing it there with a wire gutter underneath. Typically, you'd use maybe a 12 by 12 wiring gutter or a 10-inch wiring gutter and then kind of offset it off the wall with some strut. That Sol-Ark is 12 inches deep, so you do need to make sure you've got room to land those drops.
I really like the look of it, Nathan. I think it looks like a great battery. And if you got a homeowner, they do care about backup, but they also care about what's going to look like hanging on my wall for the next 10 years. So
yeah,
that wall mount makes it look really
battery.
nice.
Yeah, it's a beautiful battery, and the fact that you can install it on the wall or on a pad, indoors, outdoors, makes it very versatile. And we don't go into the installation here in this presentation, Daniel, but it installs very fast. I've made a video of installing this with a colleague on a training wall where I think the entire video was about 7 minutes. It goes on really quickly. Realistically, it goes up on your wall in about 30 minutes, and then you still have to do your conduit runs. But it's a very fast installation.
Yeah, anyone wants that video, email us, and we'll send it over to you.
Yes. So partial home battery backup is a bit different from whole home battery backup. So we're going to focus on a whole home, but let's just take a moment to review the traditional way that battery backup has been done in the US. So during a grid outage, the traditional way of battery backup, when you had smaller inverters that were not capable of powering the whole home or not capable of passing through large amperages, you would have to install a critical loads panel. And in a grid outage, the inverter is going to disconnect itself from the main panel of the home. And then that battery power can flow into the inverter, solar power can flow into the inverter if you've got it. And then that inverter can discharge back into the core loads panel of the house, those critical loads. In the event of a grid down situation, you would not want power to flow back to the main panel. And of course, that's we have anti-islanding protection in inverters, and so you are disconnected from the main panel. That means that any of the loads that you have in the main panel of the house are not being backed up in a grid down situation. The difference here on the right side of the screen, we're showing a Sol-Ark 15K. You are connected to the grid through a 200 amp disconnect. And then in a grid down situation, all of that power from the batteries or potentially from the solar as well can flow into the main panel of the house and back up all of the loads, or still not exporting anything to grid, protect those linemen that might be out there working on repairing the lines. Notice we are not having to install an additional loads panel in the house and move loads over. So as Daniel mentioned earlier, having a whole home inverter simplifies the installation process and makes it a nice clean look as well. Daniel, I mean, you mentioned the aesthetics of having that nice looking Briggs & Stratton battery on the wall, but not just that, not having conduit running all over the place because you've got multiple panels on the wall and changes that are made to a retrofitted system here. So here's an example of components that would be used to do whole home backup. You can bring up to 19 kilowatts of DC solar into your inverter. Now it will only be able to, will peak out at 15 kilowatts of solar being processed. But you can bring up to 19 kilowatts in. You've got 3 independent MPPTs in the controller. We're showing here power flowing from the main panel into the Sol-Ark inverter. I'm sorry, power flowing from the utility into the Sol-Ark inverter and out to the main panel. So that would be pass through. You can use power coming from DC connected solar. We're showing it flow through rapid shutdown devices. We've got a solar disconnect here and that coming into the inverter. And then that power can also be used to charge up and discharge the batteries. And we're showing that here as an example. We're also showing what the My Sol-Ark app looks like on the right side of the screen, and we'll get some more footage of what that does as well. Here's another example in which we've shown the integration of a generator. Daniel, why might we want to include a generator with a battery backup system?
Well, specifically on this one, we're showing off-grid, right? There is no grid. And historically, in all off-grid homes, we've always leveraged generators. Why? Because if we're going to size your solar system, so this map behind me is actually the solar insolation that the Earth receives during the worst month of the year, right? During January or December, at least in the Northern Hemisphere. And so we size your solar on your off-grid property to kind of find a balance between the two. If I size it for what this map says, your solar is going to be way oversized for summer. So what we want to do is leverage the generators in the dead of winter when we've had a big storm. We can go ahead and start that generator up using the 2-wire signal to start up the generator, charge up the batteries, and then shut the generator off. So that's a lot of ways, Nathan. And if we do talk about, an on-grid home as well, a lot of times we can be able to extend and reduce the fuel consumption of that generator as well. So a lot of ways to pull it in. You can.
Great examples.
Yeah.
I'll give one more. Right, certainly it happens, especially off grid. Certainly it happens when you've got bad weather and you just don't have solar for a week. You've got that cloudy week that comes in, and so for off grid homes, you might integrate a generator. I will point out that the majority of the off grid homes that I've seen don't use such a large generator, right? They might use a 13K. Typically off-grid houses are a little bit better designed around lower overall loads, et cetera. And so there are some ways to program a smaller generator by setting limits and setting priorities to cover loads to reduce overall battery demand. So that, yeah, maybe the generator runs a little bit longer, but you could use a smaller generator as well. We've even seen options of portable. And if you attended last week's training with Daniel, Daniel talked about the many different ways you can configure generators to support you off-grid or on-grid. And so we'll get into that a little bit here, but we're still going to focus on whole home. Now, I'm showing you here, if you do have a house with large overall loads, I'm showing you here how you can parallel a couple of Sol-Ark inverters, get that split phase 240 out of there, but parallel, so you have 24 kilowatts of continuous power, 48 kilowatts of surge power coming out of battery banks. Also showing this with our Boss 12 cabinets, your standard SimpliPHI battery here, and a DC combiner. So do keep in mind when you're combining battery banks, like 2 battery banks like this, or 2 of our 6.6 stacks, that you want to make sure that you're combining those battery banks into a single bank before drawing power out of them. And that ensures that we are balancing the power between all of the batteries that are contributing power.
Yeah.
You also want to make sure that the cable lengths that you choose when you're combining multiple battery banks into one are equal. If we have a dissimilar cable lengths, it can reduce the overall load resistance on the battery bank with a shorter cable. And that battery bank can end up doing more work, and it can overall decrease the lifetime.
Yeah, these are all in parallel, all 48-volt batteries. I will say that SimpliPHI battery you see is also available in 24 volts, which makes it a great lead-acid battery replacement for existing sites. Maybe you got an old MagnaSign or some old Outback equipment. So it's a great battery. It's either 24 or 48 volts. In this example, because it's a Sol-Ark, it's the 48 volt.
And the last thing I want to point out on the screen here, we're still showing the optimizers there, rapid shutdown devices, I guess we're showing. But I also want to point out that, when you are taking the power output of dual Sol-Arks that are parallel like this, you do want to combine them before sending that out to the load center. And so I'm showing the use of a power distribution block to combine the AC outputs of these inverters before they go into that main loads panel. And so those are things that, you can use those for battery combining as well. These come in all sorts of different configurations with, 4-aught out, 1-aught in, et cetera, or number 1 wire in, et cetera. So we did just show an example of a generator with the Sol-Ark 15k, and we're going to talk about two different ways of integrating a generator in with a Sol-Ark inverter. Daniel, what are we looking at with this one?
So we're looking at a generator coming in onto the gen port of the Sol-Ark, and these two slides I think are going to speak to how well Sol-Ark has been able to integrate generators. So in this example, we got our grid coming in up on the top right through our meter. There's our disconnect. We always recommend you installing those CTs, even though the Sol-Ark has built-in CTs. Those give you a little extra redundancy and performance there. Bring it in on the grid port. 200 amps in, 200 amps right back out to that load center that you see down there. Then we have the generator. Although it kind of looks like a portable generator, that's really a standby generator. And then we're using a 2-wire signal to start to be able to start up that generator based on the state of charge of the battery that can be adjusted in the Sol-Ark.
Excellent. So thank you, Daniel. Let's have another example where we're showing a generator. Now, of course, you do not have to include a generator in your whole home backup system, but we do know that it's common to see this, and we also have a lot of generator installers that are now doing battery backup so they can go back to their original customers and ask them, hey, do you want to integrate battery backup, because you get that millisecond transfer time. You don't see those clocks reset. The internet doesn't go down. The kids don't yell, what's happening? So here's another example of integrating I guess we don't show the generator here. Oh, we are showing the generator. Sorry, the picture.
Yeah, so this is an example of us bringing a larger generator. So when we use the grid port, we can have a larger generator than we could otherwise leverage on the gen port on the Sol-Ark.
What's the limit here, Daniel, with using a transfer switch? What's the difference between bringing the generator in on the gen port and bringing the generator in through a transfer switch?
It's 19,200 watts, I believe, on the gen port, whereas this, we can really bump it up to, I think,
200.
well, if it's 200 amps, that'd be 45.
Yep.
This, I think, is a great example, though, of how you can come out to a house, maybe that already has an existing generator, an existing transfer switch, and not really have to rip any of that off the wall.
Exactly.
We leave the transfer switch in place, right? So if the grid goes down, the generator is going to recognize the loss of utility. It's gonna not start, right? Because it's still waiting for that 2-wire signal to start.
Start, right? We're not going to use the automatic start of the grid sense start of the generator. We're still going to use the 2-wire start, and so the batteries power loads first. But if they get down, they can send that signal to the generator.
Yep, generator will start. Transfer switch will recognize that the generator has started. It's going to switch over. You can see in this example, it's showing through the generator feed through. It's going to feed over, pass into that Sol-Ark, and then start covering loads and charging the batteries. And Nathan, we got this last week, is what happens, though, if the sun is still up and the solar is producing? There's a risk.
Yeah, it depends. I mean, we've got a couple of questions on that. So I was about to ask you, what can you use that gen port for? But let me just answer that question first.
Yeah.
So we have DC coupled solar coming in on the MPPTs. If we have DC coupled solar coming in there, the inverter is smart enough to realize through sensing of the signal coming from the generator on the grid port that it's not in fact grid, and it will not backfeed that generator. If you have AC coupled solar, we do want to be careful, and so you could bring AC coupled solar in through the gen port. So I was going to ask you, Daniel, what could you use that gen port for? And I know you've got some notes on the screen. You could use it for AC solar, or you could use that generator port as a smart loads port for some loads you might want to turn off in a grid outage. So if we have AC coupled solar on there, we can do something else more clever. And what are we looking at, Daniel?
So again, what we don't want is the ability for that AC coupled solar to shut itself off, right? The Sol-Ark wants to use frequency shifting to curtail the charge of that AC coupled solar. If we add a generator into that functionality is lost. So we can either program the generator to not run during solar hours, or what we can do is leverage one of our SimpliPHI 2 load shedding modules to be a lockout module, so that if the generator comes on, that line contactor is going to open up, preventing that AC coupled solar, whether it's a solar edge, whether it may be an end phase, from ever operating while the generator is functioning.
And these lockout modules are relatively cheap as well. So as long as you have a Symphony 2 or a Symphony Choice a transfer
Transfer
switch,
switch. Yep.
yeah, you can purchase one of these. I think they're between $100 and $200. They're relatively low cost, easy way to make sure that your AC coupled solar does not cause problems with a generator. You do not have to set the generator to not work uh, during solar hours. You can have that generator come on anytime you want. It'll just turn off the solar feed. Now, keep in mind that typically, if there's plenty of solar, the solar is going to be charging the batteries and covering loads. So
Yep.
this would only be happening maybe at the end of the day where the solar is getting very weak. Batteries are discharging for whatever reason. They get low enough to start up the generator. But that lockout module is a low-cost way to make sure you're never going to have problems, and you can combine generators, AC, solar, and batteries in your whole home backup.
Lastly, I want to make sure we just talk through the rest of that slide, Nathan. We got
Sure.
about 20 minutes left, but
Yes.
what's going to happen when the grid comes back on, right? So the grid, say the power outage is over, the grid comes back on. The transfer switch will then recognize the return of utility and transfer back automatically. So that's incorporated in our Symphony transfer switch. And then essentially you're going to be running back like you normally would before. We did have one question from Liam. Is there any use case that your team has seen someone using a Briggs portable in a whole home backup system? I will say this, that my mother-in-law actually does have a generator, a portable generator. It's a quite large one. I believe it's maybe, I want to say 10 kilowatts, that has it's not 2-wire start, but it does have the button to at least crank it. And she has a twist lock, 50 amp twist lock on the outside of the house, a manual transfer switch. We're able to back up the home. Keep in mind, she has gas range, gas furnace, gas water heater. So if you do look carefully at those loads, it's possible to back up an entire home using a portable, but you want to look carefully at what you got going so you're not overloading that generator.
Well, and most customers, Daniel, that are using manual transfer switches are much more cognizant of what loads they have on. And so I can say that there's a similar example here by me where you've got a 6.5K portable. It's on a manual transfer switch between AC coupled solar and that generator coming in. You do, if you're doing that, have to be careful to make sure to switch your settings when you switch over to a portable. So that's a low cost way to bring that portable in. You do just want to make sure to let the inverter know that, hey, I have coupled a portable generator in on the gen port. So no transfer switch, or manual transfer switch, but still coming in on the gen port. So that's for a more experienced homeowner, but certainly can be done, and it's really only a few clicks on the screen of the Sol-Ark to program. Showing here an example of paralleled Sol-Arks. These are Sol-Ark 12Ks with 5 batteries. A nice use of bus bars there. I like seeing that they're pulling power off of opposite corners of those bus bars. That balances power draw out of those stacks of 5. So that's a nice example. This is not one of our cabinets. It looks like just a common utility cabinet that they've utilized, but they've put it to good use. It's in a nice looking system with parallel 12K Sol-Arks there. Here we're looking at some examples of those are 15Ks on the right and 12Ks on the left. So the system on the right has got, I think, 80 of the 5 batteries. And this is doing, I think that this is on an island off of Connecticut, I believe. The link is there. And then the one on the left is backing up a village up in Alaska. And there's, I believe, 7 Sol-Ark 12Ks and another example of maybe 80 or 100 of those 5 batteries. So those 5 batteries can be great for big systems. In the interest of time, I want to keep moving here. I want to point out just some of the common features that make that Sol-Ark 15K so great, or some of the advantages of that 15K. So one, indoor or outdoor rated. You get effortless communications with our batteries. It got 12 kilowatts of power directly from battery to cover your loads, 15 kilowatts of power to cover your loads if you got some AC, PV coming in as well. You've got 24 kilowatts with a 10-second surge capability. So if you need to start up your large loads, you've got 24 kilowatts of power from a single inverter there, 48 if you parallel them. You get 19 kilowatts of solar input from 3 different MPPTs. You can have an additional amount of solar coming in from your AC. There are a few limitations, but I think you can bring in almost 35 kilowatts of power from DC and AC solar if you combine the two. The AC solar, of course, comes through the AC bus. 200 amp pass-through, that's a big one. 100 amp generator input, 80 amp for continuous, right? So 80 amp limit for continuous power. So 19 kilowatts of continuous power. Automatic two-wire start of our generators. Stackable up to 12 of these units. So if you've got a very big install, maybe even a commercial install, whether you're doing 208 or split phase 240, you could stack up to 12 of these units. And
Nathan,
then we've been integrating with the Sol-Arks the whole time. Daniel.
yeah, I would say 200 amp AC pass-through, that's the key takeaway of this training, really, is that the ability to do whole home backup using energy storage systems is now able to be done with these hybrid inverters, just like a Sol-Ark that has this 200 amp pass-through. Until they had that 200 amp pass-through, it was difficult to do a whole home backup. And really, also, I would mention that the energy storage batteries, right, the 6.6 batteries, that they've come down in price and that they've been able to have that fast discharge rate to supply the home loads is really what's made this possible. So it really wasn't until very recently that we've had both a high quality inverter and a high quality battery to be able to do this whole home backup. And I really see the future of a lot of our energy storage systems going forward is these whole home backup architectures. So excited to see any of your installs. If you do any of these installs, please send us pictures. We'll be
Absolutely.
able to highlight you guys in some of our upcoming trainings.
You know, one thing that I did not put on that slide that we just looked at is that Sol-Ark warranties their products for off-grid. And, you know, you can't say the same about companies like Tesla. You can't say the same about other companies like Enphase that do not want their products off-grid. Sol-Ark and Briggs & Stratton offer warranties for our products in the off-grid setting. And that's an important distinguishing feature, right? Where they're backing up our products, we want you to use them off-grid. We want you to use them with grid-tied systems as well. We want you to use them in the application that fits for you. Energy independence, right? That's something that's very important. I am going to skip through this slide a little bit quickly, but keep in mind that if you are using batteries to power an inverter, you want to make sure that the output power capability of your battery is sufficient to meet the demands of the inverter. So, you know, all batteries have a limitation. It's based on their C rate, right? And that C rate output may or may not be big enough, right? And so we're showing you some examples of what the minimum recommended battery size is here to power a Sol-Ark inverter. Of course, if you've got a communicating battery like the 3 on the right, they can tell the inverter to reduce its overall output, but you are sacrificing some of the ability of your inverter if you don't meet the minimum number of batteries that are shown there on the screen. And then with that 5 battery, it is a minimum of 8 batteries to power an inverter. And so you do want to make sure that you've got that. Now you can set the settings on the Sol-Ark to limit the power draw out of the batteries. We know that that's possible. But there are most situations you're going to want to take the advantage of all of the power that Sol-Ark can output. So I'm going to keep this slide in here. You'll get this in a copy. We've got about 15 minutes left, I believe. Daniel, it's also very common for us to see 2 stacks, 3 stacks of these new 6.6 batteries, 4 stacks of these 6.6 batteries going in with a single Sol-Ark. What's the advantage of having multiple batteries with a single inverter?
Well,
biggest
you got
number one.
a larger fuel tank, right? So you can have
get a larger fuel tank. Yep.
Yeah. And what's really nice, again, about the Sol-Ark 15k and some of the other hybrid inverters that are these large ones, that they have dual battery inputs. So we're going to show you some combiners here, but what they make it really easy to be able to have dual battery inputs to bring those in. If you are going to use a single stack and you want to leverage all 275 amps of the capability of our batteries, you will need the fork adapters that will double up those dual battery lugs to bring them in.
Or we can recommend using dual sets of battery cables. So two positives, 2 negatives coming from a single stack, right? So in fact, you know, we recommend that you use dual sets of cables from a single stack, and then 1 set of cables from each of the stacks with a double stack setup. But as Daniel pointed out, you are going to limit yourself to 200 amps DC if you only use 1 set of cables. There's a single pole breaker on each of these positives that's here. And those are 200 amp breakers. So, you know, if you want to take full advantage of this Sol-Ark, like Daniel said, either use, you know, with a single stack, either use dual sets of cables coming from that single stack, or use these combiners that Briggs and Stratton makes and offers.
Nathan, I know we only got 11 minutes left, but I really like answering questions live
Yes,
because I
let's go
feel
ahead.
like it really, you know, saves me from. So anyway, Jim is asking, is there any way to reduce the 60-watt standby current when the inverter is idle? Maybe keep it in the shade so the fans aren't working as hard, or I don't know
Yeah,
if you
you
can.
know, Jim, I've got a Sol-Ark 15k running off a battery stack in my shop here right now, and I do not think there's much we can do about that. As Daniel mentioned, you know, you do want to make sure that it's not hot, but you know, I've noticed the same thing even when the Sol-Ark is idle. There is a, you know, there is a draw, and that's keeping everything inside there energized. And so there is some inefficiency. Unfortunately, it's present in just about every inverter that's out there on the market. But I don't know of a good way to you know, eliminate that. I wish there was maybe a sleep mode, but certainly you want to maintain power on your AC bus on your load side. Um, and so for me, you know, if I'm not using it, I can just shut it off and leave. So that makes sense maybe for an off-grid site when you're leaving the house and you don't need to have anything powered. But no, I don't know of any way to reduce that.
Yeah, keep it inside, right? Inside will be a little bit cooler. Inside, the batteries will stay a little bit warmer. Inside, we're gonna, you know, these things are outdoor rated, absolutely, but keep them out of the weather a little bit. I know Andy is asking a little bit about the benefits of indoor outdoor. We do have a harsh weather training. Late, Nathan, I'm letting you keep going because we're running up on time. But
Sure.
stay tuned for one of those.
So this is a quick slide. If you are combining large numbers of batteries, you might want to utilize an option. So I'm showing you 6.6 stacks, 6.6 stacks. I mentioned earlier about having cables of equal length. But you also need to have overcurrent protection on those individual stacks coming into that combiner. So I'm showing here a Sol-Ark. We've got, looks like 6 different input breakers. Sorry, not a Sol-Ark, a Midnight DC 1000 amp combiner box. And so you can purchase DC breakers together with a Midnight DC combiner box to bring up to, I think it's 10 individual battery stacks. Now we only have, you know, you can only go up to 6 on our 6.6s. So you could purchase 6 300 amp breakers here and connect them to each of your batteries. There are other ways to do battery combining though. And so, you know, Daniel, I think you and I just talked about using a 1000 amp bus bar with one of these, oh, I'm blanking on the acronym for this type of fuse, but this, you can get these in 300 amp fuses, and they're basically a surface mount fuse. Additionally, I'll show you an example of using this Class T fuse together with a Victron product. This Victron Lynx unit that's out on the market. Again, you want to make sure you're getting a Lynx unit. It's Class T power in. It's 1000 amp combiners. These are stackable. And so you can stack these. And then they have individual fuses on the positive that's coming into the bus bar. You want to make sure that you get the Lynx because this one accommodates 4-aught cabling. And you'll want to use 4-aught cabling from each of your stacks. So I'm going to skip forward because, Daniel, we've got 10 minutes of time here. I'm going to point out the inputs on a Sol-Ark 15K for whole home backup. So first off, we're looking at the DC side of things on the left side of your screen. Those are DC breakers on the positive poles coming in. You can use that as your combiner for up to 2 stacks, right? So if you've got 2 battery inputs, you can use that DC breakers as a combiner, those dual DC inputs as a combiner. They do combine to a common DC bus right after those fuses. You've got your solar inputs for DC solar. You have 3 independent MPPTs, 2 strings per MPPT. You've got paralleling communication. So if you're paralleling multiple inverters, you would come out of inverter 1 into inverter 2, out of inverter 2 back to inverter 1. So you've got closed loop communication there. Battery CAN bus. This is where the battery communicates to the inverter. So that's where you would plug your battery Ethernet comms cable in. And we do have a dongle that's included with our battery stack that you would use to come into that CAN bus port. Then you've got the generator or the smart load output. Again, there's a nice feature of the generator out or the generator port on a Sol-Ark 15K that you can use this as a battery state of charge regulated output. So you can put a sub panel on this generator port. Neutral bar and the grounding bar are here on the inverter. and then the load port and the grid port. Now, this is not on the load side of things. That's a load disconnected. It's not a load breaker, so you'll want to use a panel that's got a breaker integrated into it. So let me keep moving forward on the communications. If you're using our 3.8 batteries, this is showing you how to wire. This is called a daisy chain from battery 1 into battery 2, from battery 2 over to battery 3, etc. And then you would use one of the device ports on that SimpliPHI battery to go to the inverter directly from the battery to the inverter. No dongle needed for those. Showing you here how you would wire the 2-wire start on the Sol-Ark inverter. So if you look at the communications bar on that Sol-Ark inverter, pins 7 and 8 are a normally open pin on that Sol-Ark inverter, and that's what would be used for the 2-wire start. So when the batteries get low, pins 7 and 8 are connected to each other, and you've got this dry contactor closing, and that will start up the generator as long as you wire into pins 4 and 5 and enable 2-wire start on our generators. So showing you how to do that, Daniel's taken pictures of our 26K and our 13K Power Protect line to show you where those wires go in there. Again, you do have to disable that auto main sensing and use 2-wire start. This is directly out of the Sol-Ark manual. It's showing you what those communications wiring, what that communications wiring is. Keep in mind that those CTs that are coming in here for 4, 5, 6, and 7, those do come included with your Sol-Ark. So when you buy a Sol-Ark 8K, 12K, it comes included with 100 amp CTs, and with a 15K, you get a 300 amp CT set that comes with that. We do recommend the use of wiring troughs under the Sol-Ark. So showing a 15K here, and it's got a wiring trough underneath of it. That does make your wire runs, everything that's got to come into that Sol-Ark, much easier to do. So Daniel and I did a training wall together with a 15K, and having a 12 by 12 by 24 wiring trough underneath it sure made it easy to route the cables, eliminate all those bends that you would need on your conduit. You can also use power distribution blocks as combiners, and I'm showing you a template here from Practical Preppers. This is available online, so if you do a large number of these and are punching through conduit boxes regularly, it's nice to have a template. So this is a nice option if you're just trying to get your holes exactly right each time for getting them quick and easily. Just a few slides here. We're in the last 5 minutes of the talk. Just a few slides here on that battery setup when you've got your system built. So that is the training wall Daniel and I put together. You can see the use of that gutter under there. When you first turn your system on, you want to set up programming on your batteries. So if you have a 3-stack like Daniel and I did, you'll see a default. Some of the information comes over directly. You do want to make sure, the very first step is to make sure that you've enabled the BMS lithium battery checkbox there on the Sol-Ark. So once that's enabled, the battery bank can start communicating directly with the inverter. So enable that, set your maximum. These are global overall charge and discharge limits. Those can be set for a 3-stack up to 195 amps on the charging side. And then on the discharging side, the max of the Sol-Ark, you can set at 273 for a single stack of our batteries. The Sol-Ark will probably only use about 250 amps because that'll be around 12K for a 50-volt battery.
You know, Nathan, I know we got 2 minutes, but I feel like it's worth it to say. So we're not, there's the smart load tab. I don't believe we have a slide on this, but when we're talking about whole home backup, what we're really talking about is an off-grid home at that point. And if anybody has ever lived off-grid, if you have, please put it in the Q&A and let me know. Sometimes you have to change the behavior of how you live off-grid. For example, if you wake up in the morning, the batteries are depleted. The sun comes up, the batteries are full, maybe by noon, by 1 p.m. Once the batteries are full and there's no grid, there's nothing for that solar to do, right? That solar is just going to be kind of wasted in a lot of ways. So what we can use, using a smart load tab, we can put some luxury items on that gen port and have a smart load output so that in the afternoon, those loads will come on automatically. I always tell homeowners, go do your laundry, go do the dishes, start using that power in the afternoon when the batteries are full. We can put an EV charger, we can put other loads in that smart load tab. So using that smart load tab in this whole home backup configuration, I think is really powerful. And excuse the pun there, but it can really work and help leverage so the homeowner's behavior doesn't necessarily have to be changed as much. Nathan, I know we're got about 1 minute left,
Yeah,
but
and I
thank you
think
for
you made a
giving me
great point
that
there,
floor there.
Daniel. You made a great point. I think that, the settings, we'll send you the slide deck here that references the settings. And of course, those change depending on your system. There are also options to do time of use programming as well. And, if you're looking for more programming, we have a programming talk that's going to come up here in November where I'll talk through those programming options, including the use of the Gen port as a smart load output subpanel. And Daniel made a great point. In fact, I'm going to be leveraging that. I do have plans to do an installation on my house where I'm going to want to use the smart load output capability of a Sol-Ark to run a car charger. And I think it's a great example. Water heater, car charger, hot
Hot
tub,
tub.
pool pump, all those things that you only want to run when those batteries are full and you might not want to sell that excess solar back to the grid unless you're under NEM 2.0, right? So I'm going to jump through right here to the end. There's, of course, monitoring. You get a lot of battery information from the Sol-Ark about our batteries. And that's one of the nice things about the Sol-Ark. We also have options for cold weather in which we can integrate heaters into your batteries. And here's a nice example showing the integrated heaters. These are heating pads that go on the back side of your battery. And these can go into our cabinets. And this is a nice example done out of Buffalo. I believe this is Buffalo Solar. A nice example of Sol-Ark 15. Those are 12Ks. 12Ks combined with Briggs & Stratton batteries there in our Boss 12 enclosures. So thank you for attending. We are at the end of the hour. If you want that NABCEP certificate for your continuing education credit, there's our email, energystoragetraining@basco.com, energystoragetraining@basco.com. Send us an email. Tell us how your name should appear on the certificate, and we'll get those issued to you by tomorrow. So thank you, everyone.
Thank you, Nathan. Thanks, everyone.